Mathematics Paper 1 Linear Algebra Vector spaces over R and C Linear dependence and independence Subspaces Bases Dimensions Linear transformations Rank and nullity Matrix of a linear transformation Algebra of matrix row and column reduction echelon form congruence and similarity rank of a matrix inverse of a matrix solution of system of linear equations eigenvalues and eigenvectors characteristics polynomial Cayley-Hamilton theorem symmetric skew symmetric Hermitian skew Hermitian orthogonal and unitary matrix and their eigenvalues. To calculus real numbers functions of a real variables limits continuity differentiability mean value theorem Taylor's theorem with reminders indeterminate forms maxima and minima asymptotes curve tracing function of two or three variables limits continuity partial derivatives maxima and minima Lagrange method of multipliers Jacobian Riemann's definition of definite integral indefinite integrals infinite and improper integrals double and triple integrals means evolution techniques only areas surface and volumes 3 analytic geometry Cartesian and polar coordinates in 3 dimensions second degree equations in 3 variables reduction to canonical form straight lines shorted distance between two skew lines plane sphere cone cylinder paraboloid ellipsoid hyperboloid of 1 and 2 sheets and their properties 4 ordinary differential equation formulation of differential equations equations of first order and first degree integrating factor orthogonal trajectory equation of first order but not of first degree Clairaut's equation singular solution second and higher order linear equations with constant coefficients complementary function particular integral and general solutions section order linear equations with variables coefficients Euler-Cauchy equation Determinations of complete solution when one solution is known using method of variations of parameters. Laplace and inverse Laplace transformations and their properties. Laplace transforms of elementary functions. Applications to initial values. Problems for second order linear equations with constant coefficients. 5. Dynamic and statics. Rectilinear motions, simple harmonic motion, motion in a plane, projectiles, constrained motion, work and energy, conservation of energy, Kepler's laws, orbits under central forces, equilibrium of a system of particles, work and potential energy. Friction, common catenary, principle of virtual work, stability of equilibrium, equilibrium of forces in 3 dimensions. Six, vector analysis. Scalar and vector fields, differentiation of vector field of a scalar variable, gradient, divergence and curl in Cartesian and cylindrical coordinates, higher order derivatives, vector identities and vector equations, application to geometry, curves in space, curvature and torsions, Serret, Fernet's formulas, Gauss and Stokes theorems, Green's identities. Paper 2, 1. Algebra, groups, subgroups, cyclic groups, cosets, Lagrange theorem, normal subgroups, quotient groups, homomorphism of groups, basic isomorphism theorems, permutation groups, KLS theorems, rings, subrings, and ideals, homomorphisms of rings, integral domains, principal ideal domains, Euclidean domains, and unique factorization domains, fields, quotient fields. 2. Real analysis. Real number system as an ordered field with least upper bound property. Sequences. Limit of a sequence. Cauchy sequence. Completeness of real line. Series are its convergence. Absolute and conditional convergence of series of real and complex terms. Rearrangement of series, continuity and uniform continuity of functions, properties of continuous functions on compact sets. Riemann integral, improper integrals, fundamental theorems of integral calculus. Uniform convergence continuity, differentiability and integrability for sequences and series of functions. Partial derivatives of functions of several means 2 or 3 variables, maxima and minima. 3. Complex analysis. Analytic functions, Cauchy-Riemann equations, Cauchy's theorem, Cauchy's integral formula, power series, representation of an analytic function, Taylor series, singularities, Lorentz series, Cauchy's residue theorems, contour integrations. 4. Linear programming. Linear programming problems, basic solutions, basic feasible solutions and optimal solutions, graphical method and simplex method of solutions, duality, transportation and assignment problems. 5. Partial differential equations. Family of surfaces in 3 dimensions and formulation of partial differential equations, solution of quasi-linear partial differential equations of a first order, Cauchy's method of characteristics, linear partial differential equations of a second order with constant coefficients. Canonical form, equation of a vibrating string, heat equation, Laplace equation and their solutions. 6. Numerical analysis and computer programming. Numerical methods, that is solution of algebraic and transcendental equations of one variable by bisection. Regula-Falsi and Newton-Raphson methods, solution of system of linear equations by Gaussian elimination, and Gauss-Jordan means direct, Gauss-Seidel means iterative methods. Newton's forward and backward and interpolations, Lagrange's interpolations. Numerical integration, that is trapezoidal rules, Simpson's rule, Gaussian quadrature formula. Numerical solution of ordinary differential equations, that is Euler and Runge-Kutta methods. Computer programming, that is binary system, arithmetic and logical operations on numbers, octal and hexadecimal systems, conversation to and from decimal systems, algebra of binary numbers, elements of computer systems and concept of memory, basic logic gates and truth tables, Boolean algebra, normal forms, representation of unsigned integers, signed integers, and reals, double precision reals and long integers. Algorithms and flowcharts for solving numerical analysis problem. 7. Mechanics and fluid dynamics. Generalized coordinates, D'Alembert's principle and Lagrange's equations, Hamilton equations, moment of inertia, moment of rigid bodies in 2 dimensions, equation of continuity, Euler's equation of motion for inviscid flow, streamlines, path of a particle, potential flow, 2-dimensional and axisymmetric motion, sources and sinks, vortex motion, Navier-Stokes equation for a viscous fluid.